Docker was created to make it easy to package, share, and run software consistently anywhere.
To illustrate how things have become easier, let's look back a few years at how software used to be deployed from a development environment to production.
You build your application in your preferred programming language, relying on components like databases, web servers, or application servers. Your setup often depends on specific versions, such as Flask 3.1 versus 3.2 or PostgreSQL 14 versus 15. After thorough testing, you package the app and deploy it to production. In production, you expect the application to run seamlessly, interacting with the same subsystem components and versions used in your development environment.
While the application is designed to work perfectly in an ideal scenario, real-world situations are often more complex. To begin with, the versions of the subsystem components in production may differ from those used during development. In a real production setup, your app might depend on not just a few subsystems, but hundreds of them. To keep things simple for now, we've left out the operating system dependencies for your app and its subsystems. Introducing operating system differences can complicate matters further, since each OS component may depend on several others. If any component differs from what was used in the development or test environment, it can lead to application downtime in production.
Production downtime benefits no one. It hurts your business, your clients, and ultimately yourself. So how do containers address this issue? As the name suggests, a container packages everything your application needs: the app itself, its dependencies, and even the underlying system components it relies on.
When you ship a containerized application, you can rest assured that it will function as expected because it uses the same dependencies and environment that were tested in pre-production. Even if the host operating system differs, your application will still interact with the containerized OS components, ensuring consistent behavior across environments.
Containerized apps are more secure because they run in isolated environments, limiting access to the host system and other applications.
Containerized apps make it easy to build small, service-focused applications, a pattern known as microservices. We'll take a closer look at microservices later in this session. Containerization helps scale apps by enabling quick deployment and replication of lightweight, isolated instances across multiple servers. Containerization offers many benefits. We'll pause here for now and dive deeper into each one in the sections ahead.